Valence of electrons are the electrons that we find in the outer shell. It's important to know that we don't count electrons in d orbitals or f orbitals where all d or f orbitals are filled. So let's look at this example here. We can see that the third shell is partially filled, and so that's where we're going to look to identify the valence electrons. If we count them up, we can see that we have 4 valence electrons. The first and second shell are full. None of these electrons take any role in a reaction or in bond formation. In this case, the example is actually a silicon atom. We can be guided in determining the number of valence electrons by looking at the periodic table. Notice this is a very lazy periodic table. We have excluded the transition metals, and this is because they're generally not helpful to think about when calculating valence electrons. So let's have a look at group 1. All of group 1 elements have 1 valence electron. Group 2 elements have 2 valence electrons. Group 3 elements have 3 valence electrons. Is it getting boring yet? Group 4 has 4 valence electrons. Group 5 has 5 valence electrons. Group 6 has 6 valence electrons. Group 7 has 7 valence electrons. And Group 8 has 8 valence electrons. So you can see by looking at the periodic table, there's a really easy, nice way to determine a number of valence electrons for any atom you want to inspect. There's something else to notice from the periodic table. If we look at the rows, we can see the point at which the first shell starts, the second shell starts, the third shell starts, the fourth shell starts, and so on. So the periodic table turns into a very nice roadmap to identify the start of shells and also the number of valence electrons in an atom.